In this video, we will practice our basic matrix operations. When you subtract matrices, you simply subtract the corresponding entries in each matrix. So for example, we'll do 2 minus 1, negative 3 minus 0. 1 minus negative 3 is the same as 1 plus 3. 4 minus 7. 2 minus 2. And negative 5 minus negative 1. Again, minus negative 1 is the same as adding 1, so this will be negative 4. So this should be the answer to number 1. So for number 2, we have to not only add, but we have a scalar multiplication. When you multiply a matrix by a number, that's called a scalar. So I'm just going to keep the first matrix as it is. But for the second matrix, I will go ahead and do the scalar multiplication. So this will be negative 3 and 3 and 0 and 12. All right, I just multiplied all of the elements by 3. Now we can finish the problem by adding the corresponding elements. So 3 and negative 3, that's 0. 1 plus 3 is 4. Negative 4 plus 0 is negative 4. And 2 plus 12 is 14. Okay, so that's the answer to number 2. Now, in order to add or subtract, the matrices have to have the same dimensions. So I can tell right away that this is going to be not possible. Once I multiply by the scalar of 2, that's going to give me 2 and 8. And then if I multiply by the 3, that's going to give me 12 and 3. However, this is a 2 by 1 matrix, 2 rows, 1 column, whereas this is a 1 by 2 matrix, 1 row, 2 columns. You cannot subtract a 2 by 1 matrix minus a 1 by 2 matrix. The dimensions have to be the same, so not possible. Looking at number 4, I'm going to multiply by the scalars to start us off. So multiplying all of the elements by negative 3 gives us negative 12, positive 6, 3, and negative 15. Now multiplying by 6, I'm going to get negative 6, 12, 12, and 0. Now I can continue by adding the corresponding elements. So that's going to give me negative 18, positive 18, 15, and negative 15. So this will be the answer to number 4. All right, number 5 looks pretty complicated, but let's work from the inside out. So I'm going to deal with this scalar right here. So for now, I'm going to keep this the same. So that's 1 and 3. And then multiplying by the scalar of 5, I've got negative 5 and 20. And then I've got the 6 and the 1. And I've got another scalar out there. Let's go ahead and keep working the inside. So I'm going to go ahead and add these 3 matrices together. So I'm going to do 1 plus negative 5 plus 6. So 1 plus negative 5 is negative 4. Negative 4 plus 6 is 2. 3 plus 20 is 23. Plus 1 is 24. All right, so that's what I get when I add all of these together. Now I've still got negative 2/3. So I just need to multiply each of these numbers by negative 2/3. Okay, so when I do negative 2/3 times 2, you can think of this as 2 over 1 if it helps. So that's going to give us negative 4 over 3. And similarly, when I multiply negative 2/3 times 24, okay, you can think of it as 24 over 1 if you want, then this is going to be negative 48 over 3. But negative 48 is divisible by 3, so we need to go ahead and do that as well. So in the end, we will have negative 4/3. Negative 48 divided by 3 is negative 16, so this would be the final answer for number 5. Problem number 6. First, we multiply each element by 1/3. 3 times 1/3 is 1. 1/3 times 1 is 1/3. 1/3 times 2 is 2/3. 1/3 times 0 is 0. 1/3 times negative 1 is negative 1/3. 1/3 times 4 is 4/3. So this is what I get when I multiply by a scalar of 1/3. Oh Lord, what now though? Immediately I see that we're going to have no solution, or this is going to be not possible. This is not possible because the dimensions are not the same. This is a 2 by 3 matrix, whereas this is a 2 by 2 matrix. In order to add or subtract, the dimensions must be exactly the same. Otherwise, you know, I add 1 and 3, I add 1/3 and 1, but what do I add 2/3 with? There's nothing here. Not possible. Number 7, first we multiply by a scalar of 1/4. So 1/4 times 1/2 is 1/8. 1/4 times 1/3 is 1/12. 1/4 times negative 2, well, that would be negative 2 over 4, which is negative 1/2. And 1/4 times 1/4 is 1/16. Okay, now we multiply by the scalar of 3. 3 times 1/8 is 3/8. 3 times negative 2 is negative 6. 3 times 1/9 is 3/9, but that simplifies down to 1/3. 3 times negative 3 is negative 9. Okay, how much space do I have down here? So this can be added. I just need to add the corresponding elements. So 1/8 plus 3/8 is 4/8, which is 1/2. Okay. 1/12 plus negative 6. You know what? I feel like I should do these calculations off to the side. So right now I'm doing 1/12 plus negative 6. But in order to do this, I would need like denominators. So this would be 1/12 and then plus negative, what, 72/12. So that's going to be negative 71/12. Okay. Next I have negative 1/2 plus 1/3. I'll reuse this space over here for my scratch work. I need like denominators. So if I multiply this by 2 in the numerator and the denominator, and if I multiply this by 3, then I have negative 3/6 plus 2/6, which is negative 1/6. So there I've got negative 1/6. And finally I have 1/16 plus negative 9. So I need common denominators. I need like denominators, so I will multiply by 16 over 16. So that's going to give me 1/16 plus negative 144 over 16. So that will be negative 143 over 16. So that is it. This would be the final answer for number 7. Number 8. This looks doable. First, I'm going to keep the first matrix as it is. All right, I'm not changing anything. So I can focus on multiplying the second matrix by the scalar 3. So I will have negative 3 and positive 3 and 0 and 12. Now I can add the corresponding elements. So that will give me 0 and 4 and negative 4 and 14. So this would be the answer to number 8. For number 9, I want to work from the inside out. So let's start by multiplying by the scalars here. So if I multiply this matrix by 2, that's going to give me 2, 8, negative 4, 6, 0, and 2. Now, I need to multiply all of these elements by 2/7. 2/7 times 7 is 2. Okay, and in my mind, I'm doing this. If I do 2/7, the 7s are going to cancel out and just leave 2. All right, that's what I just did. Okay, if I do 2/7 times 14, all right, 2/7 times 14, 7 goes into 14 twice, and 2 times 2 is 4, so this will be negative 4. 2/7 times 0 is 0. All right, 2/7 times negative 7 is going to be negative 2. All right, and it's the same type of thing as I did up here. The 7s cancel out, but now I have negative 2. 2/7 times 7, we already discussed that would be 2. And 2/7 times negative 21. All right, if I do 2/7, 7 goes into 21 3 times. 3 times 2 is 6, so that's going to be negative 6. Okay, now I can add the corresponding elements. Still got this 3 out here. But anyway, 2 and 2, so that's 4. 8 and negative 4, that's 4. Negative 4 and 0, that's negative 4. 6 and negative 2, that's 4. 0 and 2, that's 2. 2 and negative 6, that's negative 4. Okay, so that is what I get from the insides. But I still have this scalar of 3. So I'm just going to multiply everything by 3. So this is going to be 12 and 12 and negative 12 and 12 and 6 and negative 12. So this would be the final answer for problem number 9. Problem number 10, I will again work from the inside out. So the first thing I need to do is multiply by a scalar of 3 over 2. 3 over 2 times 1 is 3 over 2. 3 over 2 times negative 3 is going to be negative 9 over 2. 3 over 2 times 2 is 3. And again, in my mind, I'm doing this. 3 over 2. The 2's cancel. That's where I got 3. Now, 3 over 2 times 4. Watch this. If I do 3 over 2, 2 goes into 4 twice. 2 times 3 is 6. 3 over 2 times 6. Check it out. 3 over 2. 2 goes into 6 3 times. 3 times 3 is 9. And we already did 3 over 2 times 2, and that is still 3. Okay, so this is what you get when you multiply by the scalar of 3 over 2. Okay, but now I need to bring down the rest of it. So I've still got here 2, 3, negative 1, 0, 1, 4. Okay, and all of this is being multiplied by negative 1/2 and subtracted from 1, negative 2, 2, 4, 3, and 1. So I'm still working from the inside out. So I still got to add these two matrices together. Okay, I might need some scratch work in a minute. Maybe I'll do it over here. So I need to do 2 plus 3/2. Okay, I'll erase this later, but if I do 2 plus 3/2, okay, I need like denominators. So that would be 4 over 2 plus 3 over 2. That would be 7/2. Okay, so I've got 7/2. Now I've got 3 plus negative 9/2. So if I do 3 plus negative 9 over 2, I need a denominator of 2, so I'm going to do like this. That will give me 6 over 2 plus negative 9 over 2. That is negative 3 over 2. Okay, so next I have negative 3 over 2. Next I have negative 1 plus 3, so that's just 2. 0 plus 6 is 6. 1 plus 9 is 10. 4 plus 3 is 7. All right, so this is what I have on the inside. Now all of that is being multiplied by a scalar of negative 1/2, and all of that will be subtracted from 1, negative 2, positive 2, 4, 3, 1. Okay, I'm running out of space, man. Okay, it is time to multiply by the scalar of negative 1/2. So I'm just going to go ahead and bring down the 1, negative 2, 2, and the 4, 3, 1. I'm just going to bring that on down. Okay, but I need to multiply all these by 1/2. So if I do that, 1/2 times 7/2 is going to be 7 over 4. So I've got 7 over 4. 1/2. Notice what I'm choosing to do is I'm just multiplying by the 1/2, not the negative. That's why I'm going to leave the negative sign here. I could have made this a plus sign and then multiplied everything by negative 1/2. But I'm choosing just to simply multiply by the 1/2, not negative 1/2. So 1/2 times negative 3 over 2 is going to be negative 3 over 4. And 1/2 times 2 is 1. All right, 1/2 times 6 is 3. All right, just think half of 6. And half of 10 is 5. Now, 1/2 times 7 is simply going to be 7/2. Okay, so now I've got this. All right, and I'm going to have to put the final answer over here. All right, I'll put it in a different color to make it clear. So now I'm just going to subtract the corresponding elements. So I need to do 1 minus 7/4. I'm going to need scratch paper. So if I do 1 minus 7/4, That's 4 over 4 minus 7/4. So that's negative 3/4. So I get negative 3/4. Okay, next I have negative 2 minus negative 3/4. That's the same thing as negative 2 plus 3/4. Okay, I need like denominators, so I'm going to multiply by 4 in the numerator and the denominator. So that's negative 8/4 plus 3/4, so that will be negative 5/4. Next I have 2 minus 1. So that's just going to be 1. And then I have 4 minus 3. So that is 1. 3 minus 5. So that will be negative 2. And finally I have 1 minus 7/2. So that would be the same thing as 2 over 2 minus 7/2. Don't you love how you can turn 1 into anything you want? 2 over 2, 3 over 3, 4 over 4, whatever you need to make like denominators. So then I'll have 2 minus 7. So that's going to be negative 5/2. So this should be the final answer. Okay, now we have some problems where we are going to solve for x and y. So the main thing I need to do is I need to start by taking care of these scalar multiples. So let's go ahead and multiply by any scalar that we see, starting with the 2. So this is going to give me 2 and 12 and 6y and negative 8x. So that's what I have right here. So I'm just going to bring everything else down the way it is. So I have 2, negative 4, x plus 4, and 2 minus y. Okay, so at this point, I have this plus this equals this. All right, now we can start building our equations. So I know I need to solve for x. So I can make one equation by doing this. Okay? Look at the element in the first row and the second column. So I have x plus 4, and I have 6y, and I have 1. Because I have the first matrix plus the second matrix equal to the third matrix, that gives me x plus 4 plus 6y is equal to 1. So that's one equation that I have. Now, of course, I could simplify this a bit by subtracting 4 from both sides. But you know what? I think I'll deal with that later. Okay, I need another equation, so let's look at this element. Okay, look at all the corresponding elements, the second row and the second column. Okay, I can make an equation out of all of these. Because 2 minus y plus negative 8x should equal 24. Okay, so I've got these two equations in two unknowns. So I should be able to solve this system relatively easily. All right, I think I'll just put a line right here. So what am I going to do? Now, over on the purple equation, I think I will get x by itself. I'm planning on doing substitution. So I could subtract 4 from both sides. So that will give me x plus 6y is equal to negative 3. Next, I could subtract 6y from both sides. So that will give me x equals negative 6y minus 3. Okay, I could go ahead and do my substitution right now. I could take this and I could substitute for x in the other equation right here. So that is going to give me 2 minus y. Instead of putting plus negative 8, I think I'll just put minus 8 times, and now here comes the x that I'm substituting for. X, instead of x, I will write negative 6y minus 3 equals 24. Distributing this negative 8, all right, if I multiply negative 8 times everything, that's going to give me a positive 48y and a positive 24. And I'll just bring down the rest of it. Okay, now I've got some like terms to combine. I have a negative y and a positive 48y. That's going to make 47y. So now I have 47y. Now I have a positive 2 and a positive 24. So that's going to be 26. And all of that is equal to 24. So now I need to subtract 26 from both sides. So that's going to give me 47y is equal to negative 2. Okay, just double checking because I see how ugly this is about to be. That always makes me fear that I made some kind of a mistake, which is entirely possible because there's so many steps. Okay, so this would be y equals negative 2 over 47. Okay, so assuming I haven't made a mistake, this should be the final answer. It just always makes me nervous when it's so ugly. But I'm going to press forward. So now that I know that y is equal to negative 2/47, I could take this and substitute it back in to this equation right here. So that's going to give me x equals negative 6 times negative 2 over 47 minus 3. So x is equal to 12 over 47 minus 3. Man, this is ugly. Then I need like denominators, so I'd have to multiply by 47. Okay, so that would be 12 over 47 minus whatever that is. So I've got the 141. 12 minus 141 is negative 129. Okay, answers this ugly just make me so nervous. So I've got x equals negative 129 over 47. All right, so that would be it if I did not make a mistake. I'm going to have to go back and double check. Number 12. This time the scalar multiple has a variable in it, but we will still multiply each of these by negative 2x. So that's going to give me negative 10x and 0 and 2x and negative 8x and negative 4x and negative 16x. Okay, I'm just going to bring all of this down. 20, 16, 0, 8, negative 4, and y. So I can make some equations by setting corresponding terms equal to each other. So for example, Negative 10x, well, you know, let me pick an easy one. 2x should equal negative 4. Okay, so 2x should equal negative 4. Okay, and similarly, let me change colors. Y should equal negative 16x. Okay, so y should equal negative 16x. Now look, a second ago I said, let me pick an easy one. Of course, negative 10x equals 20. That would have been easy as well, but, you know, smaller numbers, whatever. Anyway, I could very quickly solve for x on this side if I divide both sides by 2. So divide by 2, divide by 2. So that's going to give me x equals negative 2. So that's one solution right there. Now that we know what x is, I can substitute that in to find out what y is. So y is going to equal negative 16 times this negative 2. So y will equal 32. All right, so that should be the solution for number 12. Let's see. The New York Yankees won the 1998 World Series in 4 games. The matrices below show the statistics for runs, hits, and RBIs for each team in each game. So for number 13, we're supposed to write a matrix that gives the series statistics. So I'm going to do that down here. Wow, that's a big number 13. So here's a matrix representing the series statistics. So here I've broken it down, of course, San Diego and New York, and we wanted the statistics for runs, hits, and RBIs, runners batted in. And all I did to get the statistics for the entire series is I added the 4 corresponding elements in each matrix. For example, I added 6 and 4 and 3 and 0, and that's how I got 13. And I did that for all of the statistics. So this is the answer to number 13. Well, this will enable us to answer number 14. Which team had the most hits for the series? Well, this is the column that has the hits, and as you can see, San Diego had 32 hits, and New York had 43 hits. So New York had the most hits for the series. All right, number 15. What is entry T21 in the new matrix? And what does it represent? All right, the 2 and the 1, that means row 2, column 1. So here we have row 2 and column 1. So the number is 26, and it represents the number of runs scored by New York in the series. So there is the answer to number 15. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.